Can you switch the lights? I actually turned one of them off. Wrong one. No, right one, right one, right one. Okay. Hello, Internet. All right. This is more for tomorrow. Today, you're not doing what you did yesterday as far as like verifying or simplifying, let's say. Well, yeah, you are, but not in the sense of, you know, using your identities to replace, except maybe in one little instance. So I will say this, on the posted notes online, I'm going to go to the end. There are the answers that were expected of last night's homework, so that's why um, I gave you your homework back. So one thing you can do in the next 2 days is look at these answers that were expected. Don't panic. There was no, some of these it's hard to figure out where the end is as far as what you're doing. But these should be obvious when you get like one little trig things. Hopefully we are getting those, like 54 being 1. That's definitely simplified. But when you look at 61 or 59, those are the ones that are kind of hard to imagine. That's what the answer should be. And with that being said also, after that, this is previous work of some of those questions, ones that students did not necessarily do well on back in the day. Let's look at 67 real quick. Looking at 67 from your homework, it's out of order, but you can go ahead and put that in order, in your head. What's sine squared plus cosine squared? Those that have done their homework, what's sine squared plus cosine squared? 1. So that's how that yellow that I have right there in number 67, that's how you have to identify things and be able to pick out these parts. Then, once I turn this into 1 plus tangent squared is secant squared using another Pythagorean identity. So that one kind of presents itself maybe as a tough one. Looking at 60, this is called splitting this up into 2 separate fractions. And then, is this simplified compared to the beginning? I don't know. You just did something. And then 15 or 5.2, when we do the simplifying like this, it's going to be more clear what you're going to have to do. That's all I'm going to say about that. We'll talk about that Thursday. Okay, so this is why we're not writing this. This is more for what we're going to do Thursday, how we simplify what's called an identity. And I'm really going to make you be specific with your work because it's all about me reading your work when we do that. But today, all we're going to do is perform some more operations that we did yesterday. So a little bit of what is what you did yesterday, but then there's some other stuff, like some algebra. So first things first, because I want this video to be over like before you leave, kind of thing. What is the common denominator between these two situations? Just cotan. And why this actually works, and again, what I yelled at you yesterday, doing a real direct instruction in our shortened day together, is because a Pythagorean identity comes about out of this when we do this. So again, know how to get a common denominator. I know some students out there were a little fuzzy yesterday about me doing that. It's 4th grade math, man, or woman. And then, those that know what they're doing, and by the way, you get a common denominator so you can put it over a common denominator. Those that know what they're doing, what's cotangent squared plus 1? It's secant. Oh, it's not secant squared. Actually, here's a little trick for these Pythagorean identities as you get going. Cotangent squared plus 1 equals cosecant squared. Me doing this year after year after year, I know the cos go together in the Pythagorean identities. Does anyone understand what I just said there? Whereas 1 plus tangent squared equals secant squared. No cos in that one. Just a little thought, maybe. There it is. A little message there. Maybe help you out on this. Okay, then here's the next thing. What's cosecant squared? 1 over... I just want to check, does something cancel? Over, what's cotangent squared? Or cotangent, I'm sorry. Cosine over sine. Who cancels? A sine cancels, and I can do it this way, but there's one sine left there. Now, who knows what 1 over sine divided by cosine is? It actually is cotan, because this is 1 over sine times Oh, I'm actually a liar. Divided by cosine is times 1 over cosine. Right? So this is actually one of the answers. Or what is 1 over sine? Ah! Cosecant? What's 1 over cosine? No time, secant. You guys got to have these memorized. Okay, now which one's the right answer? Either one. It depends how you, express your answer at the end. Okay, so maybe some more of those, like getting a common denominator. You did that yesterday. But here's what I'm talking about here. What does this imply I do with this one when you have parentheses like this? What does this imply? Starts with a D. Now, and you better get good with this. Who knows what tan times cotan should be right away? Tan times cotan should be 1. I should not have to write cotan as 1 over tan. I should not have to write this as sine over cosine, and this as cosine over sine, and then see everything cancel. You should understand that these are reciprocals of each other. So this most certainly should equal 1 when you're done. Not totally, though, because then I also have to do this. All right, I'm just going to write it like this. Hate s as a variable. I can't write. I'm nervous about the time. Okay, then I probably could have done this ahead of time, but when you show your work, you have to break this down step by step. What's tan? Sine over cosine. I hate s as a variable. And then cosecant is 1 over what? Sine. Now this is one where we can maybe skip a step. Okay. The signs cancel because of cross multiplication. Cross canceling is really the correct term. What's 1 over cosine? Secant. So now at the end we can write this as this. And that's probably what you should be aware of in that particular question. I'll take a pause for a second, let you catch up. Maybe. Oh my word. I don't know what I'm doing. Hey, illegal math word. We tried to kill this word in the Lockport math department. I brought it back. FOIL. Now, I will tell you this. This is an absolute no-no. I see students do this all the time. 3n minus 2 squared. They square the 3n, they square the 2, and they happily get 9n to the 4th minus 4, and they're wrong! Because what does something squared mean? It means something times, say it, itself. And then this implies that you FOIL. I'm not going to do this one all the way out. There's a 3 or 9n to the 4th. There, it's actually not even negative 4. Negative 2 times negative 2 is what? 4. But then you also get a middle term, which is negative 6n and negative 6n, negative 12n. So you lost your middle term by not foiling. So really all you're going to find mostly in your homework, which you'll be able to handle, I think, without me is, all you got to be able to do is FOIL. Hey, what's B actually? What letter is that in the Greek alphabet? Anyone? Beta. Good. All right, and then being able to handle trig just like you handle variables. 3n times 3n is 9n squared. 3 cosine is 9 cosine what? Squared. That's it. And then, boom, boom. That's minus 6 cosine B. And minus 6, I'm just going to call it B instead of beta. It's easy. And then negative 2 times negative 2 is 4. You should not need me for this. This is just trig being used in algebra that you already know. And then being able to handle the like terms and all that other stuff. Should be something that you're pros at. I think we're all pretty solid mathematically. A little worried about coming from Math 3. Those worries have been, what's the word? Maybe not extinguished, but at least calmed down in my brain. So then when you get this little number 9 expression, you got to be careful. Because again, you don't just square and square. Okay? You what? You FOIL. T is not my favorite either. And then just hold off on this cosine squared for a second. And this is where this minorly stretches your brain a little bit after I'm done with this one. So I FOIL. By the way, good FOILers are good what? Yeah, back in the day, this is 1 sine t and another 1 sine t. There's 2 sine t's here. Come on. And then sine t, and sine t is sine squared t. Now this is why this is minorly different than doing just regular algebra. Did I do something wrong? What happened? What's the matter? We have a wait. Hold on. There's panic in the street. All right. Now why is this different than algebra? Does anyone notice something I could do? There's definitely a simplify trigonometrically. What do you see that can be simplified? What's sine squared plus cosine squared? This is so wild. Now, it's not an option. It's a must. This is how this gets a little different now. After you're done with a question, is there something I can simplify further? And this is one of the more popular things that happens when you do some foiling or some, algebra with trig. You end up with a Pythagorean identity that can be turned into something else. All right, what's 1 plus 1, everybody? 2. Good. And then don't factor out. This is simplify, which means get it in the most simple form. Don't think about factoring out a 2, and right now you don't have to. It's not like it's the worst thing in the world. And then the last part of this, I'll probably yammer on after the bell rings when you go off to your lunch. And I might finish the video while I'm eating my lunch. You can hear me chew while I'm doing some math. Doesn't that sound fun? Because the next part of this section is factoring, which you have to understand, factoring is the opposite of simplifying. That's why I say good FOILers are good whats? And good factors are good whats? And then actually I should throw the word distributors. When you distribute, that's simplifying. When you undistribute, that's factoring. They're just reverses of each other. Why is he yelling at us? I don't know. So the next thing you should do is you should recognize these patterns. Now, it's amazing. I have my discrete students that are seniors, many from the Math 3 area, and they don't know these basic, simple, quick factor tricks. Okay, so let's help them, CAT students that were in Algebra 2. What is this called? A difference of what? 2 squares. This is unfoil real fast because good FOILers are good whats? And if you came from Math 3, you better be a good FOILer. Well, you better get there, Chief, or else that bus is going to come around and splash you in the face with mud. So what times what equals x squared? Let's figure this out. That's why this is the first 2 terms. What times what equals 16? Just help me. Now, why do I have to put a plus and a minus? Well, first of all, what kind of 16 is this? And then the second thing is, what happens to the middle term, which doesn't seem to be here? It's gone. That's why it's plus minus. Yeah. Okay, so let's move on. All right, and then the problem with this, though, here's the problem with this class, the way it's organized now. We made a decision to do the trig first semester. Last year, we did a whole long convoluted factoring chapter like in September. And then this was in November, December, January. So you better get your factoring skills up quick. And hopefully your Math 3 has prepared you for that. All right, now, what quick factoring does this work when I have a 1 in front of this? And I don't do tables. I just put MA right there. Because when it's 1x squared, all I have to worry about is what multiplies the 12, and then the same 2 numbers add to positive 7. What are the 2 numbers? And good FOILers are good what? Because what times what equals x squared? We just put an x here and an x here. That's why this MA works. What times what equals 12? That the numbers you liked? 3 and 4, and they're positive because what's 3 times 4? 12. So I'm emulating the foiling as I factor because they are just reverses of each other. And then I check my middle term. What's 4x plus 3x? 7x. That's why we do M12A7. That adds to 7x. Let's move on. Now, I don't have that ability to do this. Because what multiplies a 6x squared? I'll answer the question. 1x and 6x, 2x and 3x. Are those my only 2 possibilities? Yes, actually for the 6x. And then what multiplies a negative 10? 1 and negative 10, negative 1 and positive 10, negative 2 and 5, or negative 5 and 2. We have a lot of combinations, don't we? So now we did this MA. Do you remember this now? Now everyone in Math 3 should have done this. No excuses. What's 6 times negative 10? That's my M number. My A number is still what? Now, the other reason people are bad at factoring is they're bad at numbers in general. Bah! Now I got to figure out a combination of numbers that when multiplied equal negative 60, when added together equal negative 11. Come on, numerate people. Tell me what the answer is. When multiplies to negative 60, adds to negative 11. This is a weird combination. Kalaka. So the two numbers are negative 15 and positive 4. Now we're going to stick with this convoluted way of factoring, but we just had someone that just tried to tell me the answer because they're a good unfoiler. That's acceptable. This is an option that you can use. Now what you learned in Math 3 is this. Split up the middle term from the magic numbers you found in the MA thing that you did there. I don't know why I wrote an 11 there. That's a 10. I saw that number and I meant negative 10. So the negative 11x does equal negative 15x plus 4x, right? And now we group. And then what we do next is take out a GCF. What's the GCF of this first two set of parentheses? A 3 and a what? And then what am I left with? No time. 2x what? Minus 5. Now the only way this works is what do I get when I factor out of this? The same thing. And what can I factor out of this one? No, not a 4. 2. And guess, lo and behold, I get a 2x minus 5. Were you going to say 3x plus 2 times 2x minus 5? You don't remember? Ah. Now, I know I'll end on this little factoring reminder. And probably when you leave, I'm going to factor trig during my lunch. And I'll post the video here. But let's talk about one more thing. Hey, what are these? A sum or difference of who? Do you guys remember soap? Soap. No one did soap?
I think I did.
Soap is same, opposite, always positive. Okay, so how does this factor? The first one is A, same, plus B, and then opposite goes here, but what goes here? A squared. Here's why. What's A times A squared, everybody? That's how you get the A cubed. And then what goes in the middle? Knowing your pattern. It is AB. And then always positive. What goes here? B squared. Why is that B squared? What's B times B squared? B cubed. That's how you get A cubed plus B cubed. Guess what happens to everything else? It cancels if you went ahead and checked this distribution. Everything else would have canceled. Good FOILers? Good factors. So that's why I did all that checking with those lines. That would definitely happen. Then, of course, a difference of two cubes is A minus B, same. Opposite of minus is plus, and then everything else falls into place the same way. And the reason this works, what's negative B times B squared? That's how you get negative B to the third. Very simple. And then everything else cancels. A times A squared is A cubed. Everything else will cancel if you cousin of FOILed. Now, as you're walking out the door, all we're going to do is that factoring, but they're in trig format. All it is, these are just trig equations or expressions that we expect to factor. So that will be the end of the video if you want to watch just that part. Okay, so here we go. Factoring trig. What do I have? 1, 2, 3, 4, 5 of them? Oh, how crazy. All right, here we go. I see a student number 7 in period 3. Okay, all right. So cosine squared minus cosine of x minus 6. Just think of this as cosine being variable squared minus variable minus 6. This is a flat out 1x squared. This is an MA'er. So I'll factor this and then I'll factor that. What multiplies to negative 6 and adds to negative 1? It's negative 3 times 2. Good FOILers are good factors. They understand that the reason this is the factored version of this is because x times x is x squared. Negative 3 times 2 is negative 6. And the middle term ends up being negative 3x plus 2x, which is negative 1x. So that's the purpose of my comment. Good FOILers are good factors. They check their answer when they're done factoring, and then they're satisfied. Okay, so, but instead of having an x, we have cosines. And then again, good FOILers are good factors. Cosine times cosine is cosine squared. Negative 3 times 2 is negative 6. 2 cosines and negative 3 cosines is negative 1 cosines. So that is definitely the factoring of that first one. Watch it again if that was too fast. Okay, next thing. Oh, I didn't have that up here in our little factoring section. But this is exactly like this, except the only thing you have to memorize, or no, not memorize, what equals x to the fourth? What times what equals x to the fourth? And the answer to that is x squared and x squared equals x to the fourth when multiplied. So this looks like this kind of scenario. And all you have to realize is, in our unfoiling, what I just said there, this is what goes here and here because x squared times x squared is equal to x to the fourth. So that's all good. Then this is a quite simple MA for the other numbers. 1 multiplies to 1 and adds to 2. 1 times 1, 1 plus 1. So this is the correct factorization of this because x squared times x squared is x to the fourth. Another 1x squared and another x squared is 2 of these x squareds running around having fun, and then 1 times 1 is 1. Good FOILers are good factors. That's the factoring of this. So what's the factoring of this? Cosine squared plus 1 times cosine squared of x plus 1. All right, because good FOILers. And then 1 cosine squared and another cosine squared is 2 cosine squareds running around. And then, of course, in both these cases, you could rewrite this if you want. You don't have to. It's not communism or Nazism making you do everything, you know, like in getting you all mad. I don't know what I'm talking about. I'll shut up now. This is an option. Both these are the correct answers. All right, next. Oh, no. Now, I know good FOILers are good factors, and I know many people can figure out this one because the numbers are kind of small to just unfoil. But I'm also going to emulate this when there's a number in front of the squared term. This emulates like this. Let's use a different variable like q. 2q squared plus 1q minus 3. And that's how you think of cotan squared. And then, you know, like I said, many people can just go ahead and unfoil because it's only going to be 2q and 1q, or 2 cotan and 1 cotan. But that's, you know, I don't want to confuse you with the q's. That's how you're looking at this. So I'm going to go ahead and do the long convoluted MA scenario. Boo, there is a number there. And then do the grouping thing. But leave it as cotans, not do the q thing. I just wanted you to recognize how this is like factoring without trig, with just general variables. By the way, what are the two numbers that multiply to negative 6 and add to 1? And it's 3 and negative 2. 3 times negative 2, 3 plus negative 2. So what you do next, I'm going to do this the bad way, the way that people mess up with their negatives. You split up the middle term because it's true, first of all. 3 cotan minus 2 cotan is 1 cotan, so this is equivalent expression. But the next thing is putting the minus second does lead to some conditions that end up messing people up. So what I do with my minuses, I make them plus and negative, and then I group like this with this fancy parenthesis, leaving the plus there. All right? Then we group, and then we take out a like term. Cotan x, 2 cotan x plus 3. And then what do I pull out of this one? The answer is a negative 1 because, like I intimated in the earlier factoring description, the only way this grouping works is if these parentheses are equal. Because then what you do, and I kind of cover that real fast in our limited time, this is called pulling a binomial GCF out of this expression. So I pulled out a 2 cotan x plus 3, and I'm left with cotan x minus 1. So this method works for any numbers that get larger when there's a number in front of the squared term. But like I said, many can just unfoil and be fine. Now, good FOILers are what? Good factors, and good factors are good FOILers because they check. 2 cotan times cotan is 2 cotan squared. It always makes me so sad, students not able to check these answers or not think of foiling when they factor. Makes me really sad. Negative 2 cotan and positive 3 cotan gives me positive 1 cotan. And of course, 3 times negative 1 is negative 3. So if you can FOIL, you can factor. You better get becoming a good FOILer. And a good factor. All right. This emulates the a cubed minus b cubed. Now this is something that just is going to have to be memorized. And it actually is supposed to already be memorized. You did this in Math 3. Remember what I said? SOAP, same, opposites, always positive. That's for the signs. The signs that we use. So same as minus. In our first set of parentheses is a wrong. It's what's the perfect cube of sine cubed? And it's sine. What's the perfect cube of cosine cubed? Cosine. So I actually want to do this emulating what did A and B represent? Whatever the perfect cubes are of this. All right, then what do you put here? Now it's this perfect cube squared. And the reason this is this is how you get sine cubed of x. Oops, I didn't put the square on there. Sine times sine squared is sine cubed. This is how you get this element of the question. Opposite of minus is plus. Then the middle term is these two multiplied together. In the expression up there, it was AB in that middle term. Here, I'll show you. AB. But it's opposite minus. So I put a plus there, which I already did. And I just wanted to say that again. So this is sine cosine. And then always positive means this is always a plus sign, this last sign. Sine. Sine. Never mind. And then the last term is this one squared. Why? Cosine squared of x times negative cosine gives me that negative cosine cubed. And then, honestly, the rest of these lines all cancel. And I'll actually show that. But this is the answer, but it's not. There's something I can do. But I just want to show this. This becomes sine squared times cosine. This becomes sine cosine squared. I just wanted to prove why this formula is what it is. And then when I do this one, this is negative sine squared x cosine. Cancel. And then this is negative sine cosine squared of x. So what I wanted to emulate is that, yes, good FOILers are good factors. If I went ahead and multiplied this out, I'd end up with the question, because that's what factoring is. It's the opposite of multiplying. So if I multiply, I'll get the question. All right? So you better understand that. Okay. Now, why is this not done? Because this is special trig. Any identities that you might identify in here that might stick out like a sore thumb? What's sine squared plus cosine squared? You're right. For those that said 1. Isn't that wild? Now what's weird is if I went ahead and multiplied this, you would not get the question because we actually changed the using an identity. So that's kind of wild, but this is a must. So when you're done multiplying or factoring, try to see if you see any identities that, especially Pythagorean, that allow us to reduce it further. You got one more? I don't know what it is. Oh, this is a difference of two perfect squares. Good answer. And the reason this is unfoilable is what times what equals sine squared? Sine times sine. And what times what equals -1? That gets me the question. And then look at what happens to these. This becomes negative sine theta plus positive sine theta, which cancels. That's not what you're doing. That was just to check your answer. The answer is this. But what I was doing is I should be able to FOIL this to get the question. Because factoring is the opposite of foiling. And I'm going to say that like a billion times till it sinks in your